Ladies and gentlemen, welcome once again. It's Miss Makansela. We are doing Industrial N2 together. Um, Lesson 26, still Chapter 4, Semiconductor Diodes. Introduction, Smoothing Capacitor Circuit. A smoothing capacitor circuit is used to generate a ripple-free DC. Smoothing capacitor are also called the filter capacitor, and its function is to convert half-wave or full-wave output of a rectifier into a more smooth DC. Lesson outcomes. At the end of this lesson, we should be able to understand the function of a capacitor, the half-wave circuit with a smoothing capacitor, the full-wave center tap with a smoothing capacitor, and lastly, the bridge rectifier with a smoothing capacitor. Linked to previous learning, a capacitor. What is a capacitor? A capacitor is a component which has the ability or capacity to store energy in a form of electric charge, producing a potential difference, which is static voltage, across its plate. A capacitor is made of two conducting sheets called the plates, and it's separated by an insulating material called the dielectric. The plates will hold equal but opposite charges, and there is a potential difference between them. Half-wave rectifier. The half-wave rectifier circuit with the sine wave input and the pulsating DC. So this is the AC input, and this is our pulsating AC output. Half-wave with a smoothing or filter capacitor. Since the pulsating DC is not enough, a filter or a smoothing capacitor will be connected in parallel with the load. This is our capacitor C1 being connected in parallel with our load resistor. The smoothing capacitor converts the half-wave ripple output of the rectifier into a more smooth output voltage. Now this is the pulsating DC that we are talking about, and using C1, the capacitor, we are going to convert it into a smooth output voltage. Now let's look at the operation with a smoothing or filter capacitor. Okay. When voltage increase during the positive half cycle of the supply voltage, meaning when point A is positive with respect to point B, capacitor stores charge or energy, meaning that it charges and reach the peak voltage, which is Vm of the AC voltage. It charges and reaches the maximum voltage here at Vm of the half of the AC half cycle. When point B is positive with respect to point A, the capacitor will then discharge this energy into the DC circuit, which is the load resistor, until the next input cycle starts again, and then our capacitor gets charged again. So now let's look at the operation looking at this waveform, whereby we say that when capacitor charge, it will charge until maximum. And because when B is positive with respect to A, our diode will not conduct. Then during that time, that's where we will have our capacitor discharging until the next half cycle starts. Then A is positive with respect to B, and then our capacitor charges. And then because we have current flowing when capacitor is charging, it charges and waits for the negative half cycle where B will be positive with respect to A, and our diode will not be allowing current to flow. And when there is no flow of current, our capacitor will kick in and discharge. And now the output waveform before and after the smoothing capacitor. We have the input, which is always a sinusoidal sine wave. And then here on the output, the lines that are shown with dotted thin lines are the output before the capacitor is connected in parallel in our circuit. Now, when capacitor is connected and we have the charging and the discharging, this is when we have our capacitor charging, discharging, charging, and discharging. The ripple voltage, this ripple voltage will be formed. Now we have three factors that our ripple voltage depend on. It depends on the value, it depends on the pulse of the frequency, the size of the filter capacitor, and the size of the load resistance. Now here we are looking at the full wave center tap. The full wave center tap with its input and then the pulsating output. Since the pulsating output is not enough, a filter or a smoothing capacitor will be connected in parallel with the load resistor. The smoothing capacitor converts the full wave ripple output into a more smooth output voltage. Full wave center tap rectifier with a smoothing or filter capacitor. The operation of the circuit is similar to that one of a half-wave rectifier, when the only difference being that the load current flows for the entire input cycle of the supply voltage. This means that the capacitor would charge during both half cycle, reducing the discharging time, and therefore the ripple voltage would be less compared to that one of a half wave. And we must remember that with the center tap, because the transformer is tapped at the center here on the secondary side, it's like we have two half waves. So having two half waves does actually give the circuit a much better output than that one of the half wave circuit. So here is our ripple. It is going to actually look a bit less as compared to that one of the half wave, and the time for discharging obviously is going to be less than that one of the half wave rectifier. Full wave input and output. Now here is just to show you that this is our input. It's a sine wave, a sinusoidal sine wave. This is our output for D1 and D2, meaning this is the output before a capacitor or a filter capacitor is connected in the circuit. Now, this output, you see it says smoothed output from capacitor. Is the output when we have capacitor connected in the circuit. So we have when our capacitor is charging, discharging, charging, and discharging. And because this is the full wave, we must remember that our discharging time is quite small compared to that one of the half wave. Full wave bridge rectifier. We are going to look at it before connecting our capacitor, smoothing capacitor. So we say that, as we already discussed, how the ripple is formed when using a rectifying circuit with four diodes to convert AC supply to pulsating DC. But in this one, we are more interested in the smoothing circuit, obviously, smoothing our output. And this is going to be achieved by connecting our smoothing capacitor in parallel with our load resistor. Now this is our full wave bridge rectifier. We have our input, our output without a capacitor, and our output with a capacitor connected. The smoothing capacitor converts full wave ripple output, which is this one of the rectifier, into a more smooth output voltage, which is this one. The principle is the same. We will have D1, D3 conducting at the same time, and then D2 and D4 conducting at the same time. So because this one is also a full wave, and with this one it's even much better than the center tap because it has four diodes. The the discharging time is much lesser than even that one of the center tap. Hence, is the bridge rectifier is the one that is mostly commonly used for power supply. So the principle will be the same, whereby when A is positive and D1 and D3 are conducting, C will charge and then discharge and then when B is positive with respect to A, and we have D2 and D4 being forward bias, then C still, it will charge and discharge. So the discharging time is quite fast. Output before and after a smoothing capacitor. Now we have our output here for a bridge rectifier only when we have 4 diodes in the circuit, and we have this output when capacitor is being connected in the circuit, and there is our ripple, the charging and the discharging of our capacitor. Lesson activity, guys, we can continue to do our exercises and also look at previous question papers. Thank you. Summary, a recap quickly. Capacitor stores energy in a form of electric field. The process of converting AC to DC is called rectification. A half-wave rectifier uses only a single diode to convert AC to pulsating DC. The center-tap full-wave rectifier uses a center-tapped transformer to convert the input AC into a output DC together with D1 and D2. But the bottom line is that it has the secondary transformer being tapped at the center. The average output of the center tap rectifier is twice that one of the half-wave rectifier. The bridge rectifier is commonly used in power supplies because it is more efficient. Lesson evaluation. Your inputs are valued, guys, so please let me know if the lesson was understandable and what do you think can be done to improve our understanding of our lessons. Thank you so much. We have come to the end of our lesson. Until next time, thank you.